Okay, let's graph these lines by plotting the x and y intercepts. And the way we'll find the x and y intercepts is by setting for the x-intercept, we will set the y value equal to 0, and for the y-intercept, we'll set the x value equal to 0. So when we set y equals 0, we get 3x is equal to 12, which means that x is 4, so we get 4, 0 as our intercept. And then when we set x is equal to 0, we get 2y equals 12, which means we get 0, 6. And that means we get an x-intercept of 1, 2, 3, 4, and a y-intercept of 0, 6. And that means that our line looks something like that. The next one, when we set our y value equal to 0, we get 2x equals 10, which means 5, 0 is our x-intercept. When we set x equals 0, we get negative 5y equals 10, which means that y equals negative 2, so we get 0, negative 2 is our y-intercept, and that means we get an x-intercept here and a y-intercept here, and our line looks something like that, except straight and going to the point. And then for the last one, numbers are a little uglier, but we get our x-intercept is equal to, when we set y equals 0, we get negative 20 over 7, which is almost negative 3. When we set our x equals 0, we get y equals negative 5, so we get an y-intercept of 0, negative 5. And so we get this point here, and we get a point almost at 3 here, but not quite. And that gives us our third line. Okay, so then it's very easy to plot from the from the standard form because of how easy it is to find the intercepts, and then we have 2 points. Okay, for each of the 3 lines, we are to write the equation in the form y equals mx plus b. So for the first one, we had 3x plus 2y equals 12. And so we had 3x plus 2y is equal to 12. We first isolate the y term, so we get 2y is equal to negative 3x plus 12. Then we divide to get y equals negative 3 over 2x plus 6. And again, that gave us our y-intercept of 0, 6. For the second one, we had 2x minus 5y equals 10. And so then we isolate our y term to get 5y is equal to negative 2x plus 10. And that's a negative 5y equals negative 2x plus 10. So then when we divide through, we get y equals negative 2 over 5, or just 2 over 5x. And then we're dividing 10 by negative 5, so we get negative 2. Notice that in both cases, when I've written the slope, I've written it as a fraction, and then separately I've written the x afterwards rather than putting the x on the numerator. And that just makes it a little easier to identify the slope in both cases. And then if we have to do any multiplying or dividing, it just makes things a little neater. Okay, then for the last one, we had 7x plus 4y equals negative 20. And so when we isolate, we get 4y is equal to negative 7x minus 20, or y is equal to negative 7 over 4x minus 20 over 4, or minus 5. Okay, so again, we quickly see we have our same y-intercepts as from above. We have 6, negative 2, and negative 5, which were the 3 y-intercepts that we got up here. We had 6, we had negative 2, and negative 5. Okay, moving right along, go to our next 2. So we can replace that question. We have, for the line in 1c above, find the distance from the x-intercept to the y-intercept. So again, going back to 1 for x minus 5 halves, y equals negative 7 over 4x minus 5 halves. And so in order to find the distance of that, we already knew that this line had a y-intercept of again, going problem, we are asked to find what the distance from the x-intercept to the y-intercept for line 1C. And so again, in that case, when we look back at our intercepts, we had that our our y-intercept, when x was equal to 0, we had y was equal to -5. So we had 0, 0, -5. And then for our x-intercept, we had, when y was equal to 0, we had -20/7. And so we're looking for the distance between those 2 points. And so if we make a quick sketch of that, we have at 0, we have at 0, -5 here, and we have -20/7, 0 here. Sorry about the writing. So basically what we do is we make this a little triangle. And so we have, the triangle looks like this, and our sides are this side right here. We'll say A is equal to 5, which is the length of that segment. We have B here is equal to 20/7. So C is equal to the square root of A squared plus B squared. So we have that C squared equals 20/7 squared plus 5 squared. And that's going to be equal to, do it over here, we get 400/49, 20/7 squared plus 25. And so what we want to do is we want to convert 25 into a fraction. So we would multiply 25 by 49, which 25 times 50 would give us 12,500. So we would subtract 125 from that, so we get 1225. So we're going to end up with 400 plus 1225/49, and that's going to be equal to 1625/49, and we were taking the square root of that. Let me use a little space. That the 1625 divides evenly into, that's 1625 is divided evenly by 25, and we know that 49 is also a perfect square. So we can factor out the 25. So again, we're going to get, and that's going to end up giving us this 25, square root of 25/49 times the square root of 65, which is then just equal to 5/7 times the square root of 65, which is about equal to 5.76. Okay, number 4. If A and B have those coordinates as given, find 2 points that are each the same distance from A as from B. What would the collection of all such points look like? So again, let's make a quick sketch here. So we have the point 5, 2, so maybe that would be here, 5, 2, and then 10, 12, maybe that would be here. And the points, all the points that are equidistant from these two fall on the perpendicular bisector of the segment that connects them. So first thing we want to do is figure out the slope going from the line that connects A and B, which would be 12 minus 2 over 10 minus 5. So that would be equal to 10/5, or that would be equal to 2. So that means the slope of our perpendicular bisector is going to be -1/2. We also know that it goes to the midpoint of A and B, and the midpoint of B is just halfway from A to B along on the X and on the Y, and halfway from 5 to 10 is 7.5, and halfway from 2 to 12 is 7, and which just is computed by taking the average of each pair. And so that means our line is going to have the equation y minus 7 equals -1/2 x minus 7.5. And so any point that falls on the line will have to make that equation true. So let's put it in a slightly easier form to work with. Y is equal to, we'll get -1/2 x negative 1/2 times negative 7.5 is positive 3.75 plus 7, so plus 10.75. Okay, so for example, if we pick the point x is equal to 0, then y will be equal to 10.75. So that would be one pair. If x is equal to 10, for example, x is equal to 10, then negative 1/2 of 10 is negative 5 and plus 10.75, so that would give us 10, 5.75. As a second point, that would fall on the perpendicular bisector, which means, in other words, it would be the same distance from A as it is from B. Okay, let's keep going here. All right, point AB lies on the line y is equal to 4x minus 2. If point AB lies at a distance of 2 root 10 from the origin, what are the values of A and B? Find both sets of values. Okay. Okay, so what we know is that if we think about AB, we know that the distance of that from the origin, so if we pick any point AB, the distance of that point from the origin is just the square root of A squared plus B squared, or we could say the distance squared equals A squared plus B squared. So substituting in our values, since we know that AB lies on the line 4x minus 2, we can say that x squared plus y squared has to equal 2 root 10 squared. So in other words, we can say that A squared plus B squared has to equal 2 root 10 squared. Or in other words, A squared plus B squared has to be equal to, when we square this, we get 40. Okay, we also know that the relationship between A and B is that B equals 4 times A minus. We can replace B and rewrite this as A squared plus 4A minus 2 squared equals 40. When we expand this, we get A squared plus, this is going to give us, when expanded, 16A squared minus 16A plus 4 equals 40. Now going back to our factoring, we're going to set it all equal to 0, and we're going to combine like terms, and that's going to give us 17A squared minus 16A minus 36 equals 0. Believe it or not, this is factorable. We're going to get 17A here, A here. We're going to get minus 2 here, and we're going to get plus 18 here. When we multiply this out, we're going to end up with 17A squared minus 16A minus 36. So that's going to give us, for our first point here, we're going to get, let me do this over here where there's a little room. We're going to get A is equal to 2, which means that B would be equal to 4 times 2 minus 2, or 6. And for our second, we're going to get that A is equal to negative 18 over 17. And when we multiply that by 4 and subtract 2, we're going to end up with negative 72 over 17 minus 34 over 17, which is going to give us negative 38 over 17. So B is equal to negative 38 over 17. So those are our 2 points. Okay, moving right along. Here now we know that, okay, find the equation of the line that is the perpendicular bisector of the segment that goes from 2, 5 to 10, 11. All right, once again, let's make our little sketch here. So we have 2, 5 maybe here, 2, 5, and then 10, 11 somewhere up here. Again, it doesn't have to be exact. And our perpendicular bisector is going to go right through the midpoint and be perpendicular. Okay, so first of all, the slope of the line that goes through 2, 5 and 11, 10 is going to be 11 minus 5 over 10 minus 2, which is equal to 6 over 8, which is equal to 3 over 4. And that is a positive slope, which makes sense given our sketch there. So the slope of our perpendicular bisector, will be equal to -4/3. We also know halfway from 2 to 10 is going to give us an x value of 6, and our y value halfway from 5 to 11 is going to give us 8. And so our midpoint here has coordinates 6, 8. So we have our equation y minus 8 equals -4 thirds times x minus 6. Since I didn't specify the form of the equation, this form is just fine. Okay, moving right along. Prove that the segment that connects the midpoints to the two sides of a triangle is parallel to the third side of the triangle. Okay, so here's what we do. We set this up as follows. We say we have one vertex here at 0, 0, one at 2a, 0, and one at 2b, comma 2c. And we can call this a general proof because basically we could take any triangle and drag it so that its coordinates corresponded to these coordinates here. Drag one vertex to the origin, put the other one on the x-axis, and have the other one somewhere up in the first quadrant or even the second quadrant. It wouldn't really matter. Okay, so now we're connecting two sides, so we'll say we'll connect these two. We know that this one has coordinates BC, which is halfway from 0, 0 to 2B, 2C, and this one's going to have coordinates, we know its y coordinate will be C, halfway from 2A to 2B. Well, we're going to take the average of those two, so it's going to be 2A plus 2B over 2, or A plus B. All right, so the slope, I mean, clearly you can see that these two are going to be parallel because they both have slopes of 0. They both have the same y coordinate. And we could have done the same thing by picking two other points, and if we picked, let's say, this one, we would have had here a0, and we would have had a slope of c minus 0 over a plus b minus a, or just b. And here, this line, we would have had a slope of 2c minus 0 over 2b minus 0, which is just 2c over 2b, and these two are equal to each other. So we could have picked any two sides, and the proof still would have worked.